Welcome back to the channel, everybody. Good to see you. Actually, I can't see you right now. You can only see me. It's like a one-way thing. Okay. We're going to do another video today about the Diazo print process. If you missed the previous episode, I'll drop a link down in the description. But basically, we're using light-sensitive, ultraviolet light-sensitive Diazo print paper, the kind of paper that was used for making blueprints, or technically blue line white prints, back in the old days of drafting before computers and computer-aided drafting and all that. This paper is not really being made anymore. It's listed in a lot of websites as being out of stock, but from what I can tell, it's not being manufactured anymore. And so this paper is available on the used market as new old stock. So one of our viewers sent me a pack of 8.5 by 11 inch paper, and I've been experimenting with it as he has. This is Peter. He's been doing this since the early 1970s, using it as a pictorial direct positive paper medium in large format cameras. I've been tinkering with this process for the last few weeks. Last week, I got this pretty good image right here of my backyard. This was not pre-flashed, and I like the fact that most of the highlights, like on the bright lit wall back behind my house, they were pretty decent. But I noticed that the branches of the tree were kind of blown out. Well, this exposure was an hour and 50 minutes, almost 2 hours. Then I did another exposure later in the day on the front of my house, in my front courtyard, and this one was more brightly lit than the other one, and I gave it an hour and 30 minutes, and it was clearly obvious that the highlights were way overexposed and blown out. So at that point, I decided that what I really needed to do was improve my methodology for exposing this paper. And what I wanted to do is, first of all, start metering the highlights of the scenes and get a sense for what exposure values are present in those highlights. And then secondly, I wanted to figure out a conversion factor so that when I meter the highlights of the scenes with my little Sekonic L308 meter, I can multiply it by some factor, and that'll tell me the actual exposure time to use in the camera. So the basic formula that I'm going to use here is, because exposure values are based on the powers of 2, I'm going to take my metered time, multiply it by this conversion factor, and that should equal the actual exposure time that the paper needs to be a good exposure. And the exponent power of 2 is a number of f-stops that you would have to multiply this time by. So in actual practice, I don't really care what the exponent is, the way it works, because I can't really use that on my meter anyways. It doesn't go that many f-stops down below ISO 3. So what I really want to do is determine two things. I want to record the recommended metered time for my exposures, and then I want to actually empirically test the paper under the same light and find out what the actual time is. And then what I'll do with those two values, we'll take the actual time, we'll call it T sub A, divide it by the metered time, call it T sub M, and that will equal our conversion factor, let's just call it F. And then what we'll do with this conversion factor is that in the future, when we want to meter a scene, we take the metered value of that scene at the f-stop of the lens on the meter and ISO 3 on the meter. We multiply that time by our conversion factor, and that'll tell us the actual time that we need to expose the paper. And of course, these two time units are both in seconds, right? The same units. So what I have to do here is some empirical testing to figure out what this conversion factor is, and I need at least 2 data points. So I need to make at least 2 pictures and record their exposure times and then the actual times I did use to calculate this factor. So what I want to do today is 2 things. First of all, I want to find out the proper exposure in this kind of light with this kind of subject matter for this lens on this camera to get a good looking print. And then secondly, I want to be taking meter readings at the same time, and I'm going to be metering the highlights. Then I need to calibrate or correlate my meter readings to the actual exposure times and figure out a conversion factor. because the lowest ISO on my meter is like ISO 3. And in practice, the sensitivity of this paper is more like below ISO 1. It's like ISO 0.000 something. So I need a multiplication factor that I can simply meter the scene with the f-stop of this lens in the meter and then multiply that time value with this factor to get the true exposure time for this paper and this lens. So this little Sekonic meter, how I'm using it is I first set the ISO on it to 3, which is the lowest ISO setting that it has. And then I take a meter reading, a reflected reading of the brightest part of the scene that I want to have detail on, which is the brightly illuminated stucco wall. And then I'm in the shutter speed or time function here on the meter, because this is not an aperture priority meter, unfortunately. The aperture on my lens is 4.5. So I have an f5.6 and some fraction, and if I go below it, I get f4 and some fraction. So the recommended time is between a 30th of a second and a 60th of a second. So I'm going to call it like a 45th of a second, roughly. That'll be the recommended metered shutter speed in this light for ISO 3. So now that I have the meter's recommended shutter speed at f4.5, what I need to do is actually do test exposures and get a good exposure in this scene like what I want. And I'll record how long that took in actual practice. And it'll be over 30 minutes, I'm sure. Then we have a simple formula that we're going to use to apply between those two times to come up with our conversion factor. And this was the first of our 2 test exposures. This was done in the morning, and I call it exposure A here in my notebook. So this went from 9:24 in the morning to about 10:30, which is roughly an hour and 6 minutes. And I set the meter to ISO 3, and I recorded the exposure value of EV 10.5. And this is using the 8x10 sliding box camera with the Xerox f4.5 lens. It was a good exposure. There's no pre-flashing on this print, so as a consequence, you'll see the shadow area here is quite dark. You can barely make out the courtyard gate and all that. But I did meter this brightly lit stucco, which turned out to be roughly middle gray, or I guess you call it middle blue, in the exposure. What I think is cool, though, the way I focused it, is you can actually see the arch here of my courtyard gate is actually reflected in the window here, which is really kind of cool. Quite pleased with this exposure. And again, this was an exposure of 66 minutes. And this was the second exposure I made. This was a little bit later in the morning. This was from 11:17 to about 12 o'clock. So this was a 43-minute exposure instead of a 66-minute exposure. I metered for the brightly lit stucco in the patio here in the courtyard next to the door. And again, my exposure value that I recorded was EV 11.1. So the first shot was EV 10.5. This was almost a full stop brighter. This, however, was pre-flashed. And I'll talk in a little bit about how I do that. This pre-flashing, you can see, definitely raised the shadow details. So what would ordinarily have been totally blocked up shadows here underneath the shade of the porch, and like in the corner here and on this side, you now have detail in the shadows where you didn't before. And oh, by the way, this picture is slightly soft because I had the viewing screen pushed forward a little bit. I needed to pull it back against my clamp where I preset the focus. So I missed focus. You might be able to tell up on the tree line behind the house on the TV antenna is a little bit more sharply focused. So anyway, I blew the focus a little bit, but the exposure was really good. Even some of the chairs, the patio chairs in the shadows in the corner, you can now see them because of the pre-flashing. So I was also trying to look for an expedient and quick way to pre-flash the paper, and that pre-flashing is a technique for raising the shadows without affecting the highlights too badly. So it helps to reduce the excessive contrast and helps to gain a little bit more of the middle tones that you want in a black and white photograph, or in this case, blue and white photograph. So what I did is I would load my sheet film holder with the paper, and we'll just pretend like it's in here. And then I'm under north-facing shade. So this is shaded daylight looking to the open north. And I figured out, at least in the winter here, just opening up the film holder and exposing it in this shade for about 30 seconds is a good exposure. And it seems to be fairly reliable. But because I want to make sure that I can do this year-round, I also took a meter reading in EV values of this shade, so that in the future, in the summertime, for instance, maybe this shade is brighter and I can adjust the time I needed to get the same amount of pre-flashing. So what I did with these two exposures, exposure A, exposure B, so I found on this website, scantips.com, highlights EV chart. They have an EV chart, so if you take the exposure value that you record, you can look up all the different combinations of f-stops and shutter speeds for that EV value. So my EV value on exposure A was actually 10.5, and on their chart, they listed 10.33 and 10.67, so I recorded both of those. And the two exposure times that the chart recommended for f4.5 was a 60th and an 80th, so I assumed about a 70th of a second would have been the optimal shutter speed on this setting, because it's sort of halfway between where my EV 10.5 would be. So what I did then is I simply took this fraction, 70th of a second, and multiplied it by the actual exposure time that it took me, which was 3,960 seconds, which is an hour and 6 minutes, or 66 minutes. And that value ends up being 277,200 as a factor. Okay, so for the second exposure, again, I looked up the exposure value that I metered it at, which was 11.1, and on the chart, it listed EV11 and EV11.33 for f4.5. So those two shutter speeds are like 100th of a second and 125th of a second. So I took about 110th of a second as being really close to EV11.1. Again, I multiplied that by my exposure time, which was 2,580 seconds, which is 43 minutes. And I come up with a factor of 283,800. So you notice the one shot was 277,000, the one shot was 283,000. So then what I did is I took those two values and I come up with a midpoint average, which I rounded off to about 280,000 as my factor for this f4.5 lens, and I'll explain why in a minute. So this factor now becomes easy to use to figure out future exposures with this camera and lens combination. And the way that works is I'd start with my 280,000 number, and if I want to multiply it by a shutter speed that my meter recommends, so for instance, if my meter recommends is 100th of a second, right? What you really are doing is just dividing this by 100, right? And so that ends up being 2,800, and that's seconds, and you want to divide by 60 to find out how many minutes that is. 2,800 divided by 60 is going to be 46 plus minutes exposure. Incidentally, since the final output of this calculation is going to be minutes, you could eliminate the divide by 60 step ahead of time by taking your conversion factor and ahead of time dividing by 60, and now the conversion factor, instead of being 280,000, is 4667. And then if you divide that by the denominator of the recommended shutter speed, you end up immediately with the number of minutes of exposure. So this will save you one additional calculation. Okay, the reason why this factor of 280,000 is really only applicable to this Fujinon Xerox lens is because I believe that it has a different wavelength transmission in the coatings, and you can kind of empirically see a little bit of that. If you look at the reflections of my ring light above here, above the table, you'll see this reflection is kind of amber colored, and this one's a little more white colored, and then the third one is kind of amber colored, and you kind of get a same sense of that on the other side. But if you take my Fujinon pictorial photographic lens for 4x5, you'll see these additional colors reflected in here, kind of a greenish blue reflection. So there's some different kinds of coatings on the lens for pictorial photography. They're trying to reduce internal reflections, but they're also trying to reduce ultraviolet light transmission, which is a common problem in landscape photography. It creates haze in the image, so they're trying to reduce that. So the coatings here between the two lenses are decidedly different, and that's the reason why I think that this f4.5 lens ends up being faster, relatively speaking, than this lens, even if you account for the difference in f-stop. Like this only opens up to 5.6, but if you do the calculation, this seems to be faster even than this one, accounting for the focal ratio difference. So I think it's this lens is pretty optimal for this process because it's optimized for UV light, I think. And a part of the reason why I think so is also because a lot of the light-sensitive printing processes that they used these lenses with were UV light-based. And I know that in Xerox machines, the light source that they use to eliminate the document when they scan your document has a lot of UV light in it. And they're trying to create an electrostatic image using that UV light, and it's much more efficient using UV light than regular visible wavelengths. So again, I think these Xerox machine lenses are pretty good for this kind of a camera system and this kind of a process. And of course, that means that I'm going to have to do the same series of tests with the 4x5 camera to arrive at its own conversion factor so I can use my meter with it as well. So to recap our results here, so to get good results, you have to have the right pre-flashing value, which is pretty easy to figure out using some empirical testing. And you need to test for each kind of lens, especially if you have lenses like this Xerox lens that handle UV light much more efficiently than pictorial large format lenses might do. So each one needs its own testing, and therefore, in order to do the 4x5 with a little bit better exposure accuracy, I'll have to do a series of tests with it as well to arrive at its own conversion factor. But I also wanted to mention that there's a few things you need to know about developing these pictures in ammonia vapors. I was using this Great Value brand of household ammonia all-purpose cleaner. This is Walmart's house brand, and this stuff is good. It's pretty strong. If you open up and take a whiff of it, which you're not supposed to do, by the way, it's pretty strong. But last week, well, because I'm getting down to the dregs on here, I went to my neighborhood Albertsons grocery store and bought their house brand of all-purpose ammonia. Wouldn't develop the pictures, and it turns out that if you smell its ammonia, it's barely any ammonia. It's like watered down ammonia. So you need the stronger all-purpose cleaner type ammonia. Again, the Walmart brand is one brand. I think if you go to some of the big box hardware stores like Lowe's Hardware, they have a cleaning section with more like industrial type cleaning materials, and so they'll have the stronger ammonia as well. Okay, that presents another issue is when you're developing this paper, do you have to do it under red safe lights in the darkroom? Well, I've just been doing so, handling the paper. I do it under red lights just to preserve the paper. I don't want to fog it right over time. In my darkroom in the winter, it's cold out there, and the ammonia needs to be closer to like room temperature in order for it to evaporate better and make fumes to develop the paper. So I've been figuring out how to use my office here as a little developing laboratory, and so I have some shaded blinds on my window, but they do transmit diffused light. So what I've been doing is I've been using like an 11 by 14 inch darkroom tray here on my table, and I have a large plastic cutting board that I use for squeegeeing my prints, and I tape the paper to that tray, the squeegee board, with drafting tape. It looks like regular masking tape, but drafting tape works really well because it'll peel off without tearing the paper or lifting the emulsion too badly in the corners. Anyway, so I tape it with the emulsion side face down, and I just set that right over this tray, shallow tray with just a little bit of ammonia to cover the bottom. And then I have a heavy towel, a large bath towel, that I just drape over the whole thing, including the sides of it, and it blocks all the light from coming in. And I can leave it here on the table throughout the day. You know, if it takes an hour or so to develop, or however long, I'll come by there once in a while and kind of agitate it just to get it stirred up a little bit. You don't want to agitate too drastically. You don't want to wet the print with liquid, because the dye will run, as you might be able to tell in this picture here. My fingers were damp with water after I had processed it, and I touched them, and the colored dye acts just like fountain pen ink. Really, it just totally runs. So just be careful to keep it dry. And also, that precludes the possibility of toning or staining this emulsion because it's water soluble. Well, this is the second video that I've done about the Diazo print process. I don't really see myself doing another video in the series unless I happen to have an update pertaining to the exposure optimization for pictorial large format lenses, in which case I'll have to come up with a different conversion factor maybe. If I do, if there's some major updates there, I'll do another video about this process. But in the meantime, I invite you guys to explore this process. Go on an online auction site and buy some new old stock Diazo paper and have at it and have fun with it. And I wish you the very best, and I hope you stay creative and have yourselves a great day. Bye-bye for now.